So let's look at another way of defining this function g of x. So one way to define it is to define it as an absolute value function. But since this absolute value is actually a piece of one line here on the left and then another piece of a second line on the right, we could also define it as a piecewise function. So this will be your first piecewise function. We're still going to call it g of x, but for a piecewise function, we're going to open up a set. So we use a set symbol here. And there's two pieces. So think of it basically like we're going to list the equation of the first line here and the second line's equation here. But then we're also going to include the domain restrictions. So it's like we're filling in 4 blanks here. So remember, g of x is just another way of writing y. So this says y equals, and now we need to write the equation for this first piece. In other words, this left-hand piece, this line. So we talked earlier about the fact that this left-hand line has a slope of positive 1/2. We see that because we would rise 1 and then go to the right 2. So slope-intercept form makes sense. If we use y equals mx plus b, then we just need to know our slope and we need to know our y-intercept. And this one's pretty clean because we can see if this line were to continue, if you can imagine it continuing, we would go up 1 and we go right 2. So I would have a point here, up 1, right 2. If the line did continue, it would continue on like so, and you'd see that the y-intercept, if it continued, would be here at positive 1. So the equation for this line is y equals 1/2 x plus 1. That's the left-hand piece. Now we didn't actually graph the entire line, we only graphed everything to the left of this point here, the vertex, and that vertex is at an x value of -2. So we want everything to the left of -2, meaning we want all the x values that are less than -2. So that's the domain restriction for this piece. We're not graphing the entire line, but only the piece that has x values less than -2. Now we move on to the right-hand side. The right-hand side is a line that has a slope of -1/2, so it's just the opposite. And we can clearly see its y-intercept here. Its y-intercept is -1. So the equation for this second piece is y equals -1/2 x minus 1. But again, we don't want the entire line. We want the line that's the piece of this line that's everything to the right of the vertex, which is at x equals -2. So we want everything to the right, meaning we want all x values greater than -2. So then the last question is what to do with -2. Right now, if I left my function the way this is, -2 is not included. So if I left it like this, that would essentially be the absolute value graph, but it would have a hole in it that would look like this. If I left it as is, here at -2 I would have this open dot. And I'd still have the v, but I wouldn't have a point here at -2, which is not what I want. I need that to be filled in. In other words, I want that to be included on my graph. So I have to be sure to come in here and include -2 on one of these. So either you make the top one less than or equal to, or if you prefer, you can make the bottom one greater than or equal to. You just choose one or the other to include -2. And this is your first piecewise defined function. Some people will just put commas here in between the function pieces and the domains. Other people will actually use the word if. I like the word if because if I read this, it says y is equal to 1/2 x plus 1 if x is less than -2, and y is equal to -1/2 x minus 1 if x is greater than or equal to -2. So you can put the word if you want, but it's not required. You could do commas or you could just have a space there. Our first piecewise defined function.